Hello, and welcome to another exciting video about simplifying radicals. And this time we're going to talk about tackling radicals when we have multiplication. So let's take a look at our notes for today. Directions say simplify. Well, when we look at this, we see the square root of 10 times the square root of 8. What we did before in the last couple videos was we tried to separate square roots. Well, now we have the ability to work backwards and go and multiply them together. So when we multiply radicals that are underneath with radicals that are underneath. So we have 10 inside the radical and 8 inside the radical. So when we multiply those, we get the square root of 80. Once we get to this point, we're going to use the strategies that we learned in previous videos. Look for the perfect square factor. The largest perfect square factor divides into 80. In this case, it is 16. So we're going to turn square root of 80 into the square root of 16 times the square root of 5. And we all know the square root of 16 turns out to equal 4. Square root of 5 is still going to be the square root of 5. We can't simplify that any further. So our final answer is 4 square roots of 5. Okay? We're going to continue on with this multiplication. So taking a look at number 2, we have negative 4 square roots of 5 times the square root of 10. You notice this is a little bit different. We have a negative 4 in front. What I tell all my students is you multiply outside with outside. Well, what's outside of this square root? A 1. So negative 4 times 1 is negative 4. And then we multiply inside with inside. So the square root of 5 times the square root of 10 is the square root of 50. Sorry about that 5. I know, a little bit ugly, but this is a little bit tricky for me. So the next step is we still have that negative 4 on the outside, but we break apart the square root of 50 like we did in previous problems. And the largest perfect square factor of 50 is 25. So 25 times what gives you 50? 25 times 2. So we go a little bit further. So we have negative 4 times the square root of 25 is 5 times the square root of 2. We can't simplify. And finally, we want to put this multiplication together. And negative 4 times 5 is negative 20 square roots of 2 for our final answer. Let's take a look at a couple others. I really like this number 4 over here. It's a unique one, but it's pretty neat how it works. So again, we have all multiplication going on here. 3 square roots of 12 times the square root of 12. So multiply outside with outside. So 3 times 1 is 3. And 12 times 12 is 144. Now conveniently, 144 is a perfect square. The square root of 144 is 12. So the 3 is still on the outside times the square root of 144 becomes 12. And 3 times 12 is 36. Now, if you're really sneaky about this, you might have been able to write this a little bit differently. Rather than actually multiplying 12 and 12, we could have written this as 3 times the square root of 12 being squared. And square roots and squares undo each other. So we could have avoided that multiplication and then undoing the multiplication by simply writing it as 12 squared. So the square root of 12 squared, the square and the square root cancels out, and you're left with 12, which, as you see, is still 36. So that's how we multiply radicals together. Now, we're going to start to see other types of multiplication. In this case, this looks like we have some number outside of parentheses. Well, we've done this before, but without square roots. You have some number times a sum. So what we're going to do is take the square root of 6 and distribute it to both of these terms. So we're going to have the square root of 6 times the square root of 2 plus the square root of 6 times 5. Now, some of you guys are going to want to multiply this 6 and 5 together, but we're going to hold off on that. Again, come back here. We have the square root of 6 times the square root of 2. There's a 1 in front of the square root of 6, and there's a 1 in front of the square root of 2. So 1 times 1 is 1. We don't typically write it, though. And then you multiply the inside together. The square root of 6 times the square root of 2 is the square root of 12. Plus, here we have a 1 square root of 6 times 5. The 5's not inside the square root, it's outside. So 1 times 5 is 5. And then we only have a square root, so we have square root of 6. Now, we might be done, but look, are there any factors of 12 that are perfect squares? And if you remember back from some of your previous videos, we know that 4 divides in nicely into 12. So, square root of 12 becomes the square root of 4 times the square root of 3 plus, now, can we find something that divides into 6 that's a perfect square? You might want to turn it into 2 times 3, but neither of those are perfect squares. There are no factors of 6 that are perfect squares, so we won't be able to simplify that. So simply rewrite it as 5 square roots of 6. Now, when we take the square root of 4, we get 2 square roots of 3 plus, we said we can't simplify this 5 square root of 6, 5 square roots of 6. And what you've learned in a previous video about adding and subtracting radicals, we can't add these together because the only way to add radicals is when the inside, the radicand, is equal. Since 3 and 6 are not equal, that's as far as we can go. So the answer is 2 square roots of 3 plus 5 square roots of 6. Let's take a look at some others. Oh, this one looks a little bit tricky here. But we're going to take our square root of 6 and again distribute it to the square root of 10. So the square root of 6 times the square root of 10. Then we're going to take the square root of 6 and distribute it to this negative 3 square roots of 2. So minus the square root of 6 times 3 square roots of 2. I just put that minus out front because a positive times a negative is a negative. Now, we're going to multiply these together. And the square root of 6 times square root of 10 is square root of 60 minus, and again, multiply outside with outside. So 1 times 3 is 3. So square root of 6 times the square root of 2 is square root of 12. So that's all the multiplication, but we still have to see if we can simplify each of these. So is there any factors of 60 that are perfect squares? Yes, there is. 4 divides into 60, and you're left with the square root of 15. So 4 times 15 is 60, minus 3 times, any factors of 12? Yes, we've already done this one. Square root of 4 times square root of 3. Again, organization is going to be very important to help you so you don't miss out on steps. So the square root of 4 is 2 square roots of 15 minus 3, and the square root of 4 becomes times 2 times the square root of 3. And we're just going to neaten this up. So our final answer should be 2 square roots of 15 minus 6 square roots of 3. You might want to break this square root of 15 into 5 and 3, but neither of those are perfect squares, so that is not helpful. This is as far as we can go. Okay? So those are 2 examples of distribution. What about if we see something like this? Oh, we got a square outside of a set of parentheses. We're going to want to distribute this too, but you can't distribute powers. So what does this really mean? It means we have 2 of these. Square root of 2 plus the square root of 3 times another one. Square root of 2 plus the square root of 3. How do you multiply these 2 things? Well, this is a binomial, and that's a binomial. And remember back, all the way back in chapter 9, we talked about multiplying 2 binomials, and we're going to FOIL. So first is multiplying the square root of 2 times the square root of 2. Square root of 2 times the square root of 2. Then the square root of 2 times the square root of 3. But these are both positive, so we've got to put a plus sign between them. Square root of 2 times square root of 3. Then we go to square root of 3 times the square root of 2. So plus again, because it's positive. Square root of 3 times the square root of 2. And then square root of 3 times the square root of 3. So plus again, square root of 3 times the square root of 3. Now, square root of 2 times square root of 2 is square root of 4. Plus, square root of 2 times square root of 3 is square root of 6. Square root of 3 times square root of 2, guess what? That's another square root of 6. And then square root of 3 times square root of 3 plus square root of 9. What's the square root of 4? It's 2. Plus the square root of 6 plus the square root of 6, because we can't simplify those. 2 and 3 are not perfect squares, so you can't break that apart anymore. and then plus the square root of 9 is 3. Now, are there any pieces we can add together? Yeah, we can add this 2 and 3 together and get 5. Can we add the square root of 6 and square root of 6 together? Yes, if you think back to adding and subtracting radical expressions, as long as the insides are the same, which they are, we add the outside. So how many square roots of 6 do we have here? We have one of them plus another. Well, 1 plus 1 is plus 2. 2 of what? 2 square roots of 6. We're going to handle one more. I know this is pushing it for time, but I think this last one will be able to help us out. This might be a little bit complicated with all these pieces, so let's be organized. Number 12, we're going to take this negative 2 square roots of 2 and distribute it to each one of those. So we're going to FOIL this out. So negative 2 square roots of 2 times this square root of 2. Then negative square roots of 2, negative 2 square roots of 2 times this square root of 3. Well, what's a negative times a positive? It's a negative, so I'm going to put a minus sign there. 2 square roots of 2 times square root of 3. And next we're going to take negative 5 square roots of 3 and distribute that to each of these, or do the inside or the inside and last. So minus, because negative times positive is negative, 5 square roots of 3 times the square root of 2. And then negative times positive here is another negative. So negative 5 square roots of 3 times the square root of 3. So that is all of our FOILing work. Now we have to look at each individual one here. Okay? So that's the first thing we multiply. Outside with outside. So negative 2 times a 1 is negative 2. And square root of 2 times the square root of 2 is square root of 4. Next one is negative 2 square root of 2 times square root of 3. Well, negative 2 on the outside times a 1 on the outside is minus 2. Square root of 2 times square root of 3 is square root of 6. Next one. Negative 5 on the outside times a 1 is negative 5 square roots of 6. And the last one, negative 5 on the outside times a 1 on the outside. So minus 5 square roots of 3 times 3 is 9. Now we have to simplify as much as we can here. Okay? So we have negative 2, and the square root of 4 is times 2. We can't break apart square root of 6. We can do 2 and 3, but neither of those are perfect squares, which is not helpful. So it's still minus 2 square roots of 6. This, again, is the square root of 6, so minus 5 square roots of 6. And minus 5 times the square root of 9 is 3. So let's see what we can do to kind of draw this all together. Negative 2 times 2 is negative 4 minus 2 square roots of 6 minus 5 square roots of 6 minus 5 times 3 is 15. Can we combine any like terms? Well, negative 4 minus 15 is negative 19. And negative 2 square roots of 6 and negative 5 square roots of 6, they're both square roots of 6 terms, so we subtract the outside terms. Negative 2 minus 5 is minus 7 square roots of 6 as our final answer. Again, thank you for joining me on this wonderful lesson of simplifying radicals when we have multiplication. I hope you have a wonderful day and enjoy the rest of the videos to come.